They called it the War of Fire. Cities burned from the sky, jungles turned to ash, and even the air seemed to shimmer with heat. But what most people don't know is that, somewhere between the bombs and the flames, a group of chemists quietly created something remarkable. A simple paste that could stop fire itself. Not armor, not magic. Just a bucket of chalky chemicals and a desperate idea to keep soldiers alive. This is the forgotten story of the fireproof paste of World War II, a discovery born from fear, chemistry, and survival. During World War II, fire wasn't just a weapon. It was everywhere. It came from flamethrowers sweeping across trenches, from incendiary bombs dropped on cities, and from the burning wreckage of tanks and aircraft. For soldiers, it wasn't the bullet you never saw coming. It was the fire you couldn't escape. Cotton uniforms burst into flames in seconds. Wool melted and fused to the skin. And on the battlefield, there was no time to stop, drop, and roll. So the question arose, could fabric itself be made to resist fire? Could chemistry save lives when armor could not? Around 1940, as both Allied and Axis scientists raced to develop new chemical weapons, a few began studying the opposite: chemical defenses. At small laboratories in Britain and the United States, researchers realized that some minerals reacted strangely to heat. Instead of burning, they released gases that could smother flames. Borax, ammonium phosphate, sodium tungstate, cheap, harmless compounds that behaved like invisible shields. It was simple science, but revolutionary thinking. What if soldiers could brush a paste made from these compounds onto their uniforms? What if ordinary fabric could buy them 10 extra seconds, the difference between life and death? The tests started small. Cotton swatches, dipped in mineral mixtures and exposed to open flame. The untreated fabric caught fire instantly. But the treated ones didn't burn. They bubbled, blackened, and then extinguished themselves. It was a spark of hope. By mid-war, this idea had turned into an actual military experiment. The U.S. Army Quartermaster Corps developed a recipe simple enough for field use: 1 part borax, 1 part alum, mixed with water and clay dust to form a thick, milky paste. Soldiers could coat their uniforms, tents, or sandbag linings, anything that needed protection. The results were astonishing. Treated cloth resisted direct flame for up to 10 seconds. On the battlefield, those 10 seconds could mean crawling out of a burning tank, or pulling a wounded friend to safety. The paste wasn't fancy. It looked like wet plaster and smelled faintly of chemicals. Once dry, it left a chalky texture that stiffened the fabric slightly. But it worked. In field reports, soldiers described moments where flamethrower bursts ignited everything around them, except their treated gear. Some even improvised, mixing local clay and borax from supply depots to make their own batches. It was survival chemistry, science stripped down to its most practical form. Yet, it wasn't perfect. Heavy rain washed it away. It added weight to uniforms, and reapplication was needed every few weeks. But for those in demolition teams or tank crews, the trade-off was worth it. So, how did it actually work? When heat struck the coated fabric, the paste didn't melt. It transformed. The borax and phosphate broke down, releasing non-flammable gases like water vapor and carbon dioxide. These gases smothered the oxygen layer around the fabric, starving the fire. At the same time, the minerals formed a glassy char, a thin shield that blocked more heat. It was a primitive version of what modern scientists now call intumescent fire retardants, coatings that expand, cool, and self-seal when exposed to flame. In other words, the soldiers of World War II were wearing early prototypes of the same chemistry that protects firefighters today. After the initial trials, the formula spread quietly through the Allied ranks. Workshops in Britain, Canada, and the US produced barrels of the stuff. In the Pacific, engineers coated tents and vehicle covers to resist napalm attacks. In Europe, it was brushed onto tank interiors and bomber seats. Some factories even pre-treated fabrics before shipping them to the front lines. A new kind of invisible armor, made not from steel, but from science. It's easy to overlook discoveries like this because they don't explode, fly, or roar. They just prevent disaster. But behind every soldier wearing that treated uniform were chemists working through the night, mixing compounds, testing flames, and writing reports no one would ever read. Their invention saved lives without ever making headlines. When the war ended, the paste faded from military use, but its legacy burned brighter than ever. Civil defense groups promoted borax-based coatings for curtains and shelters during the Cold War. And in laboratories, scientists refined the formula, embedding flame retardants directly into synthetic fibers. By the 1950s, this led to new materials like Proben and, later, Nomex, the very fabrics used in firefighting gear, pilot suits, and space technology. All of it tracing its roots back to a crude wartime paste made in buckets behind the front lines. Today, the same principle still works. Mix borax and boric acid in warm water, soak a natural fabric like cotton or canvas, and let it dry. The result? A cloth that won't catch fire immediately. It chars, bubbles, and resists flames for several seconds. For survivalists, that's enough time to prevent disaster. It's simple chemistry, rediscovered. Because in survival, knowledge is your first line of defense. The story of the fireproof paste isn't just about formulas or experiments. It's about human adaptability under pressure. When everything was burning, someone asked a different question. What if we stop the fire before it starts? That mindset, practical, creative, desperate, saved lives. It reminds us that survival isn't always about strength or technology. Sometimes it's about understanding the world deeply enough to make it work for you. Think about it. A handful of minerals, some water, and a brush. That's all it took to change the odds for countless soldiers. And yet, few history books mention it. It wasn't glamorous, it wasn't strategic, but for the ones who walked through flames and lived, it was everything. Every flame-resistant uniform, every firefighter's jacket, every pilot's suit carries a fragment of that forgotten invention. A legacy born in chaos, preserved through chemistry. It's a story of quiet heroism, proof that sometimes the smallest ideas have the biggest impact. So next time you see a firefighter standing safely near an inferno, or a pilot wrapped in flame-proof gear, remember this: their protection began not in a modern lab, but in the muddy fields of World War II, when a few scientists decided that a simple paste could defy fire. If you enjoyed uncovering this forgotten chapter of wartime innovation, make sure to subscribe, because every episode reveals another story of human ingenuity, how necessity, fear, and creativity changed the world in ways we've almost forgotten. The fireproof paste was more than just chemistry. It was resilience in its purest form, proof that even in the darkest times, knowledge can save lives. Sometimes the greatest inventions aren't the ones that destroy, but the ones that protect. And this was one of them.